All right, guys, are there any questions on any of the assignments thus far? Or yeah, we have 2 so far. Okay. What we're looking at today, and what we're going to be working with today, is long division. Now, it's been probably quite a while since y'all have worked a long division problem out by hand, because most of the time, if we did this here, 29,682 divided by 13, we'd really just grab a calculator and type it in. Now, if we did this by hand, we would draw or set this up with 29,682 inside our kind of little house and 13 on the outside. Now, what would we do first? See how many times 13 will go into what? 29. Well, we would start with 2, exactly. And, well, 13 won't go into 2, so we move over 1. And see how many times will 13 go into 29? Twice. And then we'll do 2 times 13. And 2 times 13 is 26, because we multiply it and then place 26 under 29, and then we would subtract. 29 minus 26 is? And then our next step would be to drop down the next number, our 6. Drop down the 6. And then we would repeat the process again. How many times will 13 go into 36? 2. Because 2 times 13 is 26. Because if it was 3 times 13 is 39. So it's a little too big. Now at this point we can subtract. And 36 minus 26 is? And then we repeat the process again and bring down the 8. And we see how many times does 13 go into 108? 8. Then we can do 8 times 13. 104. And then we would put it under 108, and then we would subtract. And if we subtract it, we get 4. Bring down the 2. Exactly. Then our next number would be 3. And we do 3 times 13, as we've already said, would be 39. And we would subtract, which will tell us that this is 3. Now, since we've run out of numbers, we could start a decimal, put 0.00, and continue on if we think it will end. But if we want to stop here, if we want to write the remainder, we would say it would be 3 over what? Because 13 is what we're dividing by. Yes? That's what we have left over. And really, in each part of this step, we're slowly decreasing the number inside our division. We're slowly decreasing this by 1 at a time. We're trying to take the number down and reduce it down all the way till we can't reduce it anymore. Or we can't divide 13 into it anymore. So any questions on this here? So what we're going to do with long division is a similar process. You don't have to write this down. Because whenever you divide a polynomial f of x by a non-zero polynomial divisor d of x, you get a quotient q of x plus a remainder r of x over d of x. Now in that space, let's go on and do our first one. Now, I'm not going to go to the first example. I want to do one that actually works out evenly first. And what we're going to do is we're going to divide x cubed plus 3x squared plus 3x plus 1. And we're going to divide it by x plus 1. So right there in that space where we have on the first one, we're going to do it there. Now, the way we set this up is going to be almost the exact same way as what we did with the previous one. So the number that goes inside here would be our x cubed plus 3x squared plus 3x plus 1. Now, if there are any gaps, any powers that aren't listed, we need to fill them in. So for this here, the biggest exponent is a 3, yes, because x to the third. So since x to the third is the biggest one, we'll need a term with x cubed, a term with x squared, a term with x, and a constant term. We need them all. So if we were missing an x squared or an x, we would need to fill it in with 0x or 0x squared. We need each one of them. Now the one that goes outside would be our x plus 1. Any questions on this so far? Now, when we're dividing, it's going to look a little different than the one we did previously here. But when we're working this through, what's happening to our number that is being divided? Well, it's getting smaller and smaller. We're reducing one term at a time going across. And that's really what we're going to be doing with dividing these here. We want to reduce it one term at a time. So looking at what's being divided by, our x cubed plus 3x squared plus 3x plus 1. What term would we want to eliminate first? The biggest one. We want to go with x to the third. That's what we want to eliminate first. And what we're going to do is we're going to use this x plus 1 to do it. And when we did the long division, well, the numbers we wrote on top are kind of what's going to be remaining, what's going to be the quotient for this. And it's what we multiplied by. So to eliminate x to the third, I need to multiply this here by something to make x and x to the third be the same. What can I multiply x by to get it to be x to the third? And we're going to put it above the x squared. Okay, my marker's back. So we're going to multiply them together like we did with the long division. So we're going to do x squared times x plus 1. Well, x squared times x is x cubed, like we wanted. And x squared times x is plus x squared. Put it right underneath. X cubed plus x squared. Guess what we're going to do next? We would subtract. Any questions on this here before we subtract? Okay. What is x cubed minus x cubed? 0. That's exactly what we want to have happen. We want the biggest power to cancel out first. Now let's subtract the next one. 3x squared minus x squared. 2x squared. Okay. What would we do next? Drop down the 3x. Okay. All right. Should have done that in purple. Forgot I'd already used green for something else. So what do you think we'll do next? Well, so at this point, yeah, we're just going to repeat the first step, what we just did. Because we did our first main step, and what we've done so far is really to get x cubed gone, yes? What do we want to eliminate next? The x squared term. So we have 2x squared, yes? So what do I need to multiply x by to get 2x squared? Positive 2x. So over here, we're going to take 2x times x plus 1 to figure out what's going to go underneath. Well, 2x times x is, which is exactly what we wanted the first term to be, yes? 2x times 1 is plus 2x. And then we would subtract. 2x squared minus 2x squared is 0. That's exactly what we want to have happen, because we want to eliminate one term at a time. Now we'll take 3x minus 2x, which is then we'll drop the plus 1. And then we repeat the process again. So what times x gives me x? Positive 1. And we could do the multiplication step out here. 1 times x plus 1, which is x plus 1. Or 1x plus 1 would work as well. And then we would, x minus x is 0, like we wanted. 1 minus 1 is 0. And whenever we have a remainder of 0, it divides evenly. So the solution for this here is x squared plus 2x plus 1. Questions on this here? Let's look at the next one. All right, so we're going to set it up. So inside is going to be x cubed minus x squared. I don't know why I wanted to put plus. Minus 2x plus 8. And what goes on the outside is x minus 1. So we need to eliminate this one term at a time. So the first thing we need to eliminate is the x cubed. So we're going to see what times x squared gives me x cubed. X squared. Yeah, x squared. So we're going to do x squared times x minus 1. Well, x squared times x is x to the third minus x squared times negative 1 is negative. And then we would subtract. X cubed minus x cubed is 0, just like we wanted, because we want that first term to cancel. Now the next one is negative x squared minus negative x squared. Well, the negative and negative would make a. So negative x squared plus x squared is? It cancels out also, because it'd be negative 1 plus 1, which is 0. So here, that's fine, because both of these do cancel, and we would bring down what? A negative 2x. I'll just keep it in blue. But we have an issue here, because how many terms do I have over here? I have x and negative 1. Yes, we have 2. How many do I have down here? 1. We could put this here. I'll put dashed. The term here that it's 0x squared, which would have just put a 0. we don't have to do that. Because it canceled out, we can say that it is gone. So all I need to do is just bring down the next term. We're just going to bring them both down because we need at least 2. Okay. Let's look at our next step. What times x gives us negative 2x? Negative 2. Because we already have the x to the correct power, we just need the negative 2. So we're going to multiply x minus 1 by negative 2. Well, negative 2 times x is negative 2x like we wanted. And negative 2 times negative 1 is plus 2. And then we would subtract. And negative 2x minus negative 2x is going to be 0, because the negative and negative would make a positive, so negative 2 plus 2 is 0. Then we have 8 minus 2, which is 6. Now 6 is going to be our remainder. And there's nothing that we can do to it to try to continue this process on, because adding plus 0 really doesn't change anything, because we'd have to create new terms. We can't just create terms for this here. So our answer would be x squared minus 2 plus what over what? 6 over x minus 1, yes. Because when we did it before where we had 6, or the first one that we looked at, 3 over 13, because 3 was the remainder and 13 is what we were dividing by. Here, what we're dividing by is x minus 1. So it's going to be the remainder over x minus 1. Now this is kind of a side note, but just looking at the fraction, what is the degree of the numerator? Or let's go a different way. What's the degree of the denominator of that fraction? Degree is the, yeah, it deals with the x, but it's the biggest what? Exponent, yes? So for this here, x minus 1, what is the biggest exponent? 1. What's the degree of the top? 0, there's not an x, yes? So is the degree of the top less than the degree of the bottom? That's how we know we're done. Because when we're dividing, the degree of whatever we're dealing with here is obviously it's bigger on top. There's nothing on bottom. But the fraction for the remainder, once the degree is less than what we're dividing by, our divisor, then we're done, because it can't go into it anymore. And that will always be the case. Questions on this here? Let's do another one. We feel comfortable with these so far. They're not too complicated. They're just very tedious. A lot of steps. So what goes inside would be what? To the 4th. Plus? Almost. Because we have x to the 4th, we have x to the 3rd. What are we missing? Then 5x minus 1. So for either one, if we are missing one of the terms, we need to put it back in. So since the biggest power was 5, we need 5, 4, 3, 2, 1 constant term. We need them all. And that goes for what goes outside as well. Because if it was on the outside, if we just had the x squared plus 2, we need to put in 0x. It won't really make a big difference, but we do need it. Any questions on this here so far? So we have it all set up, yes? Now we're looking at what? We need to eliminate 2x to the fourth, yes? So we're trying to look and see what do we need to multiply x squared by to get 2x to the fourth, yes? Yes. Question? So what do we need to multiply x squared by to get 2x to the fourth? 2x squared. Now the x squared, there's a way that we can kind of get to it without having to think too much about it. On the outside, what we're dividing by has how many terms? 3, yes? Because we have the x squared, 3x, and 2, yes? Starting at 2x to the fourth, if I go over 3 counting it, because 2x to the fourth would be 1, 3x cubed would be 2, and our third term would be the 0x squared, yes? Because that's how it would line up. So our first one would be x squared. Kind of those x squareds line up, don't they? 3 terms over. Maybe it doesn't work that way. Here I have how many terms? 2. I go 2 over, where am I at? X squared, isn't it? That's the first one we started with. Got 2 terms, yes? If I go over 2, I'm at. Y'all see how that works? It kind of gives you an idea of where we're starting. But if you don't see that, that's fine. Because we can still work it the other way. Because 2x squared times x squared will give us 2x to the fourth to eliminate that first term. 2x squared times x squared plus 3x plus 2. 2x squared times x squared is 2x to the fourth, exactly what we wanted. 2x squared times 3x is plus 6x cubed. And 2x squared times 2 is plus 4x squared. And then we will need to subtract. And this year I would suggest writing that subtraction however many times we need to do it, just so we can keep track of it. And we'll go from left to right. 2x to the fourth minus 2x to the fourth is 0, exactly what we wanted. We want that first one to cancel. 3x cubed minus 6x cubed is 3x, negative 3x cubed. 0 minus 4x squared is negative. And then we drop down the plus 5x. Any questions on this so far? Then it would be? Huh?
It makes more sense now.
Yeah, and that's what this is. Yeah, that's good. I'm glad that it finally makes sense, because sometimes doing more of these help. Yeah. Oh, with the 3 terms? So what do we need to eliminate next? Negative 3x squared, yes? Yeah, we would need negative 3x. Because 3x times x squared, x times x squared is x.
Oh.
Yep.
Okay.
So we'll do negative 3x times x squared plus 3x plus 2. And negative 3x times x squared is negative 3x cubed, which we want. Negative 3x times 3x is negative 9x squared, and negative 3x times 2 is negative 6x. And then we will subtract. What is negative 3x cubed minus negative 3x cubed? 0. Because really the negative and negative give us positive, so it's negative 3 plus 3, which is 0, like we want it to be. Negative 4x squared minus negative 9x squared. 5x squared. Because negative 4 plus 9, because the negative negative with the 9 would be positive, give us 5x squared. Then we have 5x minus negative 6x. Well, the negative and negative again. 5x plus 6x is plus. And then we do drop down the negative 1. So this here would be our last one. Because do we have any other numbers left up there? No. So this is the last one. So we need to see what times x squared gives us 5x squared. 5. So we would put plus 5. So lastly, we're going to multiply, do 5 times x squared plus 3x plus 2, which will give us 5x squared plus 10. 5x squared plus 15x plus 10. And we would 5x squared minus 5x squared is 0. 11x minus 15x is, and negative 1 minus 10. So we do have a remainder, yes? Now, I'd mentioned this earlier. What is the degree of the remainder here? It would be, what's the degree of what we're dividing by? So we are done, because we can't divide it any further. So what we can do is our 2x squared minus 3x plus 5, we can add to it negative 4x minus 11 over x squared plus 3x plus 2. And that there would be our answer. No, but there is another way that we could have rewritten this. If I wanted to, since both the numerators are negative, or really the 4x is negative, I can factor that negative out of the top and get this here. And the main reason you would do that is not so much that they're both negative, it's just a little weird sometimes to leave a negative as the first term, but I will take it in either way. Any other questions on this here? Let's see what we have. Y'all want to see another one of these? No. Look through the rest of them and see if there's one that looks more challenging than one we've done. Because all of this does work the same. It's just that same repeated step that we did each time over and over again. Any questions on this here? Okay. If there are no other questions on this here, I need to get this out. Homework. Is going to be on page 187. It's going to be problems 5 through and I will tell you all this here. What we're doing tomorrow is synthetic division. Y'all are going to like it more than this.